Welcome to the GCSE Maths Advantage. I'm Dr. James Carter, and every episode I'm going to break down one topic, show you where the marks are, and give you a quick win you can use in your next exam. Whether you're targeting a grade 7 or pushing for a 9, let's get into it.
Look, this one fact will shock you. Last year's AQA Higher paper lost more marks to rounding mistakes than any other single cause. Students knew the method, but they lost marks by writing the wrong limits or by forgetting to carry bounds through to the end. Sound familiar? In the next 12 minutes, I'll make bounds simple. What 1dp or nearest centimetre actually mean, when a limit is inclusive or exclusive, and how to carry those bounds through an area or percentage calculation so you don't lose easy marks.
The concept. Start simple. When a question says a measurement is 12.3 to 1 decimal place, it doesn't mean the value is exactly 12.3. It means the true value could be a little smaller or a little bigger. To 1dp means the measurement was rounded to the nearest tenth. So the lower bound is 12.25 and the upper bound is 12.35. Say it with me. Lower is 12.25, upper is 12.35. That interval covers every actual value that would round to 12.3.
If you see to 2dp, you split the last place, 2 decimal places, into half of the unit at the next place. So 4.56 to 2dp has lower 4.555 and upper 4.565. For to 2 significant figures, the idea is the same, but you work with the first 2 non-zero digits. For example, 230 to 2SF becomes lower 225 and upper 235, because 230 rounded to 2SF covers those values.
Nearest centimetre. If a length is given as 5 centimetres to the nearest centimetre, the true length is at least 4.5 centimetres and less than 5.5 centimetres. Note the typical exam language. Nearest uses a half-unit split. For exam answers, we usually write these as inequalities or bounds. Inclusive versus exclusive is a small but important point. If a measurement is exact, or written like 3 centimetres exactly, that can be inclusive. But when something is rounded to the nearest unit, the upper bound is often exclusive. Practically, say 4.5 less than or equal to length less than 5.5 to show you understand which end is included.
Let me show this on a quick number line in words. Imagine a number line with 4.5, 5.5 and 5.5 marked. Everything from 4.5 up to, but not including 5.5, would round to 5.0 to the nearest centimetre. So we include 4.5 because anything from 4.5 will round up to 5.0. But we exclude 5.5 since that would round to 6.0. Say it again. Include the lower, exclude the upper, unless the question says inclusive or gives an exact limit.
Now, a short worked numeric example. Question. A radius is 3.2 centimetres to 1dp. Give the bounds for the radius. Pause. Think. Lower 3.15. Upper 3.25. If you need the diameter or area next, carry these bounds through. Don't round the bounds themselves until the final answer, unless the question asks you to. That preserves the method marks.
The concept summary. Convert the stated accuracy into a half unit at the next place. Write lower and upper bounds clearly, and be precise with inclusive or exclusive language. Don't drop notation. Write the inequality or the upper and lower values.
Exam technique. Here's where marks are hiding. Examiners reward 2 things above all: evidence of method and careful labelling. For a bounds question, you will typically get M1 for writing the correct lower bound, M1 for writing the correct upper bound or showing you carried those bounds through a calculation, and A1 for a final answer in the required form. So even if your final numerical answer is imperfect, showing the bounds usually earns method marks.
Take a common 3-mark question. A length is 12.3 centimetres to 1dp. Find the range of possible areas of a circle with this radius. mark breakdown, M1 for lower and upper radius bounds, M1 for setting up area equals pi r squared with those bounds substituted correctly, and A1 for the final range labelled with correct inequality or bracket notation. If you skip writing the bounds and jump straight to an answer, you often lose the first M1, that's throwing away marks.
A typical wording trap. Students write 12.3 plus or minus 0.05 and leave it at that. The examiner wants you to evaluate the limits or carry them through. Write 12.25 less than or equal to r less than or equal to 12.35, or r is between 12.25 and 12.35. And then show area equals pi r squared with r equals 12 and r equals 12.35 substituted. That shows method and is exactly what the examiner checks.
Also, label units, area in centimetres squared, and keep your working visible. If you see a composite calculation, don't round intermediate bounds too early. Examiners will award method marks for correct substitution, even if your final rounding is slightly off. Quick win. A 5-step routine you can write in the margin every time you see a measurement. Step 1. Read the accuracy phrase aloud to 1 dp or nearest centimetre. Step 2. Convert to the half unit at the next place. Step 3. Write lower and upper bounds explicitly with inequality signs. Step 4. Substitute those bounds into the formula before rounding. Step 5. Label your final answer with units and the word bounds or range. 2-second check. After you finish, quickly ask 2 questions. Did I include units, and did I carry bounds through before rounding? If the answer to either is no, stop and fix it. This tiny habit catches about 90% of the silly errors I see in mock papers. Worked example. Let's apply the routine. Question. A radius is 3.2 centimetres to 1 dp. Find the maximum and minimum area of the circle and give the percentage change between the extremes. Step 1. Bounds for r. 3.15 less than or equal to r less than 3.25. Step 2. Area formula. A equals pi r squared. For the minimum area, use r equals 3.15, so A min equals pi times 3.15 squared, which approximates to pi times 9.9225, which approximates to 31.16 centimetres squared. For the maximum area, use r equals 3.25, so A max equals pi times 10.5625, which approximates to 33.19 centimetres squared. Write both with units and say A min less than or equal to A less than A max to be clear.
Mark's commentary. M1 for writing 3.15 and 3.25, M1 for substituting into A equals pi r squared, A1 for giving the numerical range with units. If you then ask for percentage change, take A max minus A min over A min times 100. That method line is another M1. The final percentage rounded correctly is an A1. And remember, show the subtraction and the division. Write it down, don't just think it.
Now the substitution check. Put one value back into your original rounded statement. If r equals 3.15 gives am equals 31.16 centimetres squared, does that round sensibly if the question later asks for to 1 dp? If not, revisit rounding steps. This prevents inconsistency between your bounds and your final rounded answers. Common pitfalls and teacher notes, quick hits for parents and teachers. Pitfall 1, confusing significant figures with decimal places. Teach students to ask which digit is the last accurate digit and work from there. Pitfall 2, dropping the inequality and writing a single number. That loses method marks. Pitfall 3, rounding intermediate bounds too early. Always carry the exact bound values through the method, then round at the end. Classroom hint. Give students a 2-minute starter where each measured value must be converted into bounds and labelled. Simple repetition builds the habit. Parent tip.
When checking homework, ask your child to read their bounds aloud. Hearing 3.15 to 3.25 helps spot errors faster than reading silently.
That's your quick win for today. If this helped, share it with a friend who's revising. You'll find more worked solutions and a downloadable bounds checklist at jcacademyonline.co.uk. Until next time, trust the process and nail that exam. Stay curious.